Hi there, this is video 722. It is about applications, and I think there's about 5 videos where we practice this. So real life situations can be modeled using parabolas and quadratic equations, projectiles falling, and I had to draw this because in the cartoons. Okay, I grew up on the Roadrunner Hour. I'm more or less okay. I don't think it's gonna hurt anybody. So in the cartoons, Wile E. Coyote would run out, and then he'd get that look of, oh my goodness, there's no more cliff. And then he would go straight down. That's what happens in cartoons. In the real life, if Wile E. Coyote did it, it would be more that. You'd get a lovely curve because he'd still have some horizontal velocity, but then gravity kicks in and he starts falling faster and faster, so the parabola is going to get steeper and steeper on you. And actually in the background, if I go this way, you can see the bridge, and it doesn't quite look like that, but oh, all right, go this way. You can see, nope, things reversed. That arch there in the bridge in the background, that's going to be a parabola too. All right. Anyway, if you're not sure where to start on these ones, my answer to everything in almost every class is, if you don't know what to do, draw a picture. Start out with a sketch of the parabola. If you have an equation, calculate the vertex. Right? And once you think about where that vertex is, it often answers a whole bunch of your questions, because a lot of times it's what's the maximum amount of money you could make from this, or how high did the ball go, or a whole bunch of stuff like that always happens at the vertex. Oh, my bad. Wrong there. That one. Their symmetry makes things easier. So if you know how long it takes to get to the maximum, you know that if to get to the maximum something took 3 seconds, it's going to take 3 seconds to get to the bottom to get back to where the ground level was because of symmetry. Okay. And don't worry if the questions use variables besides x and y. Actually, as I was doing this, I found it a lot easier to understand if they didn't use x and y. Okay, enough of that talk. Let's get going on a question. So, some children are playing at a local splash pad. The water jets spray water from ground level. The path of the water from one of these jets forms an arch that can be defined by the function f of x is equal to negative 0.12 x squared plus 3x, where x represents the horizontal distance from the ground in feet, and f of x is the height of the spray pad, also measured in feet. Okay, so when we started this chapter, we talked about functions, and okay, truth be told, I forgot to talk about function notation. Okay, and that just means f of x. You can think of that as y. Right? It's just a different way of writing it. And the one thing I did, and this is normally what I don't do, but it makes more sense to me, is I rewrote this equation because it says x represents the horizontal distance. So I made it a distance because that's going to remind me what that is. And the f of x is the height of the sprayed water. So I like height is equal to 0.12 distance squared plus 3 times the distance. Made so much more sense to me than trying to look at this. I mean, it's okay, and it's awesome if you can remember, but when it's written like this, I don't have to keep going. Which was it? What did f of x stand for? So, all right, let's do a quick sketch. And I'm talking like a really super quick sketch. So this is ground level. And okay, so here's where the fountain starts. We know it's going to be negative. So it's going to go something like that. That's as exciting as my sketch is. It's an arch. So what is the maximum height of the water? Well, where does the maximum occur? That's going to be your maximum height, and that is in the middle, and it's at the, yes, it's going to be at the vertex. Remember I warned you up here? Calculate the vertex. So vertex is minus, so P is equal to minus B for 2A. Remember, the moment you see, in this case, a D with no power in it, you have to use the standard form of figuring out where the vertex is. You can't just read it directly off there. All right, so, whoops. A is equal to negative 0.12, b is equal to 3, and c is equal to 0. So minus b over 2a, so p is equal to minus 3 over 2 times negative 0.12 is going to be minus 3 over negative 0.24 and negative 3 divided by negative 0.24, 12.5. Okay, and that is essentially your x-coordinate, or the one that's in here. So 12.5, and that refers to the distance. And I'm going to put horizontal distance. Okay, so essentially, I just answered this one. How far away from the opening is the maximum height? 12.5 feet. But this question says, how high did it go? Well, the height is basically the y value, the second one. So I need to take this number and plug it into this equation, just like we always do, and generate that. And I'm just sad that I don't have more room. So I'm going to do this. I should have known better when I made this worksheet. So height is equal to negative 0.1 to d squared plus 3d. Height is equal to negative 0.12 times 12.5, right? We just plug it in, plus 3 times 12.5. Height is equal to, where can I put it there? 12.5 squared. Negative 0.12 times 156.25 plus 3 times 12.5. I realize I'm writing pretty small to make everything fit. H. All right, so I need to go 0.12 times 156.25. All right, so that's going to give me negative 18.75 plus 37.5. 18.75. Just recheck that. 37.5 minus. All right. And this is going to give you your height. So, back to our question. Basically, there's your answer. It's 18.75 feet. How high is the water at 2 feet from the opening? Okay, so 2 feet from the opening, the distance from the opening is represented by d. So all I need to do is try to figure out where to write this. Height is equal to negative 0.12 d squared plus 3d. And it's telling me it's 2 feet from the opening. So all I need to do is substitute that in for the d's. So this is d. So height is equal to negative 0.12 times 2 squared plus 3 times 2. Height is equal to negative 0.12 times 4 plus 6. Height is equal to excuse me, 0.12 times 4, that should be 4.8. Negative 0.48 plus 6. So that's going to be 5.52 feet. So at 2 feet, this is 12 feet long. So at 2 feet, this point is 2 and 5.52. We probably just go height is equal to 5.2. We can round. All right, last question. How far away from the ocean is the water when it hits the ground? Well, this one's actually pretty easy, and we don't have to do a whole lot of calculations. So from here to here, we said was 12.5 feet. Oops. And that takes us up to its maximum. And because of the beautiful symmetry of the parabola, this distance is also going to be 12.5 feet. So 2 times 12.5 is going to be 25 feet on the opening. So that's where the symmetry comes into comparison. And it, almost always with the symmetry, it's going to be, you're looking basically for this point down here. And it's, you just double what it is to the maximum. And there we go. That's the end of the video.